I want to begin by just doing some simple arithmetic with different kinds of roots. So not so much focus on exponents right now, just focusing on different kinds of roots here. So A should be review. 3 times 12, you can multiply those together, they're radicands. So you get root 36, which of course is just 6. All right, 5 times 25 is going to get you 125, and the cubed root of 125 is just 5. 3 times 27 is 81. And 81 is a perfect fourth power. It is 3 to the fourth. Letter D, as long as these are both radicands, you are allowed to reduce the fraction, so you get root 49, which becomes just 7. If I was doing letter E, the first thing I would do is see if 4 and 1024 reduces, which it does to 1 and 256. After I reduce my fraction, I would check to see if you can actually do the quartic root of 256, and you can. It's actually 4, so the answer is just 1/4. 5 does go into 625 125 times, and the cubed root of 125 is 5. So we're going to change gears and do problems that are a little bit trickier than what we just did. If you notice, 3 over root 5 is not considered finalized because you have a root in the bottom. So normally you would just multiply the top and the bottom by root 5, and your new answer would be 3 root 5 over 5. That trick is not going to work for, say, the cubed root of 2. So if you're thinking, oh, I'll just multiply by the cubed root of 2, that's not going to work. So what we're going to do is focus on a goal. We want the power of our radicand to match our index. And what I mean by that is, if you notice, 2 is to the first power right now. So this is the power of the radicand. I want that to either match that or be a multiple of that. So right now it's not. So what we're going to do is we're going to multiply by the cubed root. So whatever kind of root we have in the bottom is the same root you have to use when you're rationalizing. And right now I have 1, 2. I would need 2 more to make 3 of them. So I need 2 more 2's. And what you do at the bottom, you have to do the top. So up top, I'm going to get 1 cubed root of 4. On the bottom, I'm going to get the cubed root of 2 cubed. And that's going to simplify them. That's the same thing as saying 2 to the 3/3. That's just 2 to the first. So the answer is cubed root of 4 over 2. So whatever the radicand is here is what you're going to be left with. You're going to find that your exponent that's inside is going to cancel out with the index. So we'll try it again. What you don't want to do for this one is think, well, right now I have 127. So I need 3 more. You are allowed to do that by all means, but you're going to have a lot more work to do before you're done with the problem. And we want to work smarter, not harder. So I pick up on the fact that 27 is a perfect cube, so I'm actually going to change it to its cube form of 3 cubed. And if you look at that and think, well, I have 3 3's right now. I just need 1 more. So we just need a 3 to the first. So up top, I'm going to have 2 times the quartic root of 3. And on the bottom, I'm going to have the quartic root of 3 to the fourth, which is just 3. And now I'm done. Now if you look at number 3, 54 is not a special number. There's nothing to a power that gets you 54. However, 54 does contain something. It contains 27, which is 3 cubed. So what I would do is break 54 into the cubed root of 27 and the cubed root of 2. And you can change the cubed root of 27 into 3. So this is actually what the cubed root of 54 simplifies to. So the only thing that's the issue right now is the 2 that's under the radical. So that's the part we have to rationalize. So we're going to have the cubed root of, we need 2 more 2's. And what I'm going to get is 3 cubed root 4 on top. And on the bottom, I'm going to have this outside 3. And what's going to happen is the cubed root of 2 cubed is just 2. So I get 3 cubed root 4 over 6. And because 3 and 6 are both outside a radical, or not inside a radical, you can go ahead and reduce those. So your final answer is the cubed root of 4 over 2. So the question is, what do you do if you have a fraction inside a root? So the first thing I would do is see if you can reduce your fraction. In this case, you can't. The second thing I would do is break it into 2 roots. So you have a 5th root 7 over a 5th root of 8. And the issue with this answer is, again, the radical in the bottom. But I realize 8 is a special number. It can be written as an exponent. So I'm going to change 8 into 2 cubed. And I need this 3 to become a 5, so I need 2 more 2's. So if I do 2 squared times 7, I get 28. And on the bottom, I'm just left with 2. And now I'm done. So what I'll do is I'll wait till the next video and we'll kind of just go through a mixture of practice problems and see how those go.